Before I get started, of course, OWASP does not endorse any commercial company. We are a nonprofit, vendor-neutral charity. But I gotta say thank you to my employer, White Hat. They have basically paid my way to travel the world for the last 2 years. I've hit 42 countries, hit pretty much every OWASP chapter. I've had a chance to have my employer fund a lot of my volunteer work throughout the world for the OWASP Foundation. I'm very grateful to my employer for that. So before we get started, I want to provide a warning, the warning label for this talk. Look, this is just an awareness document. There are more than 10 issues in application security. And please do not try this at home. Do not base your entire application security program off a top 10 list. This is a start. This is an initial awareness. And we'll dive deep a little bit in this presentation, but please be careful using this document. It's meant for initial awareness, it's not a comprehensive program. Fair? Let's get to it. So, proactive controls. How do we get started building an application security program within our organization? Look, the reality is when you look at application security, we are babies at this. We are new at this compared to other elements of information security. And we still have a lot to learn. We have a lot of maturity to build in our industry around application security. And so we still have a ways to go. So this is where I feel we're at today, a great place to get started building your own program. So number one, security requirements. Is this an exciting topic? No, it's not. In fact, most of the things that are going to really make a big difference in your company around the building of secure software, it is not exciting. It's not like hacking some global application and getting in CNN getting in the news because you're such a great hacker. This is fetch wood and, what is it? What's the saying again? Fetch wood, carry water. This is just hard work. And it's to some degree, it may be boring to some of you. But that level of minutia, that level of just daily grind is what we need to build secure software. So what do I mean by secure requirements? There's two basic kinds of security requirements, functional and non-functional. When I talk about a functional requirement, this is something that is that a little bit better? There we go. When I talk about a functional requirement, this is something that really needs, that can be testable by a QA professional. It's a visible feature in your application. It's a standard workflow. Any standard user will run across this security feature. This is something like the forgot password workflow. When the user has forgotten that password, they trigger forgot password, they enter in some information, they're given a link or go through some workflow. We can test that by QA staff pretty deeply. Also, like re-authentication during a change password feature. Security features that are functional that we can test. Now, there's a whole batch of non-functional security requirements that we really can't test for easily with our standard QA staff. These are invisible quality features behind the scenes of an application. This is stuff like query parameterization. This is building your database query resistant to SQL injection. We'll talk about that more later. Or how you're doing crypto around password storage. Users aren't going to see this stuff. Normal QA staff is not going to run into this. And my conjecture here is I can come up with a list of about 10 functional requirements that I can attach to every project. I can come up with a list of about 10 non-functional requirements that I can attach to every project. I'm not blowing the ocean here, talking about 20 basic requirements, and I can solve 90% of all application security problems just by doing that. Look, your developers are smart people. It's really difficult to build even basic software. It is. It's a difficult art, takes a lot of work and effort, a lot of pressures on developers coming from all angles. If you let them know early on what you expect in the software, your chances of getting it go up dramatically. So, basic stuff. Next, security architecture in design. This is a strategic effort where you have the business, technical, and security stakeholders all agreeing on what these functional and non-functional security properties of software are going to look like before it's built. Again, is this exciting? No. But again, the earlier you address these issues, the cheaper it's going to be for your organization to achieve secure software. Even on some of your lowest priority apps, you're getting forced by compliance, by your business partners, by your customers to build secure software. And that pressure is only going to increase in the next couple of years. So when you get the key stakeholders together and agree on what this is, again, we're not trying to boil the ocean here. I'm not a big believer in some of the more detailed and evolved security architecture design processes, the deeper you get into this, the returns diminish quickly. So I want to spend just a few days. Let's get this on the table. Let's get the basics on the table so we can, again, design software in a secure fashion early on in the life cycle. When you try to fix these bugs deep in production, especially the more complex ones, multi-step workflows, the cost to fix is off the chart. When you're designing it, when you talk about security design early on, the cost goes down to very little to nothing. So I think of this as like a 2 to 3 day process when we're beginning to design software. An example of what I mean by this is state. So when you're passing data around an application, you can pass state through a request as a hidden parameter. You can pass state through a web session, a standard session. You can pass state through a database. And developers get this wrong all the time. And I think it's something that we can think about way in advance before we actually build that software. So just some things that we have to think about. I'm not going to go into too much detail about these topics. Next, key requirement, in my opinion, to what it takes to build secure software, leverage the security features that we already have in frameworks and languages. And this is only getting better. Let me give you one quick example of a framework that addresses a problem. So one of the big problems I harp on is access control design in a web application. How do most developers build access control into a web application today? What do you think? I'm sorry, access control. They tend to do hard-coded roles in code. If the user is a this, or if the user is a that, then we'll let them have access. This is a radical anti-pattern. I'll talk about this right now, actually. So we have Apache Shiro. Apache Shiro is a very high-quality Java project that was written by not security folks, but really high-end professional developers who also had solid security knowledge. And they were addressing a problem with the federation of your session. When you have a very highly hit web application with a lot of users throughout the world, the standard web session becomes useless. It's not workable for large, highly hit global applications. So you need to distribute, cluster, federate that session throughout a global infrastructure. This is why Apache Shiro was built, because that was lacking in all the core Java frameworks. They still are to this day. And so Apache gives us a good authentication layer, the session management, and a really good access control layer that no other framework gives us. This is something that we can leverage in almost every Java application. Suppose we're building a Star Wars game, and we want to check if the user is allowed to wield a lightsaber. Traditionally, developers will code it like this. Well, if the user is a Jedi, they're Obi-Wan, if the user is a Padawan, Luke, or if the user is a Sith Lord, of course, Darth Vader, or if the user is a Jedi-killing cyborg that was trained by a Sith, this is, of course, General Grievous. And every time we have a new character or type of character that we use in the video game, we have to go and push code. We have to change new code very often in thousands of places throughout the application. This is an anti-pattern. We do not want to design code like this. There's almost no need ever to code like this. This is a traditional hard-coded role-based access control. Shiro is the only Java framework that does proper capabilities-based access control built in from the ground up. You can still do role-based access control if you want to. I still think it's an anti-pattern. Here, I don't care about the role. I'm just checking about the feature. If the user is permitted to wield a lightsaber, then let them do it, end of story. Once I code like this, I'm coding to the feature, not the user. I'll never have to change this code ever again. And I don't want developers to build this from scratch. This is actually a very complicated feature to build. I want them to leverage a well-vetted, high-quality, actively maintained security library or framework feature that does this for them. Here's an example of data contextual access control, something that role-based access control doesn't even address in any way. Role-based access control addresses hierarchy and static roles for users, where here we have a more data-driven request. It's not just the role. We're asking, is the user allowed to drive a certain vehicle? I get to drive my Winnebago. Nishi, you are not driving my Winnebago. I'm sorry. But I shouldn't be driving your Winnebago either. But maybe if you're married, you can definitely drive your Winnebago, your husband's Winnebago, because it's yours anyways, right? So here the user's making a request to drive this vehicle in a game or some kind of feature. So we say, let's get the integer of the Winnebago that we're currently operating on, force that to an integer, and then say, is the user permitted to drive Winnebago of that number? We push this code, it's data contextual. No other framework provides a default feature like this. We'll never have to change this code again. Even if we completely change our access control mechanism underneath the hood, that this will stand the test of time in terms of not having to modify code, which we want to avoid in secure software. We want to modify code as little as possible. Also, cross-site request forgery. This is not something that we should deal with as a programmer. This is something that should be built into the framework. This is a quick example of home routers getting owned by cross-site request forgery. There's a lot of material on this risk. I'm not going to get into it now. I just want to put it out there that cross-site request forgery, again, developers shouldn't be dealing with this. This is something our framework should provide. And in the Java ecosystem, we're late on this. Spring, one of the most popular Java frameworks, only started offering cross-site request forgery defense only a couple weeks ago, actually. Zane, does Ruby on Rails give us built-in CSRF defense?
I believe so.
Yeah, I think Ruby 3 and 4 gave it to us. It's built in. Devs don't have to work at it. PHP frameworks have had this built in for some time now. So again, it's an example of leveraging a secure framework, using the right piece to get something secure or more secure. Let's talk about authentication and identity. I could spend hours just talking about this, and I have, sorry Matt, and I'm going to mention a few quick things that I think are important in terms of things that developers need to do themselves, that frameworks aren't going to handle for them for the most part. So password defense. I want to talk about first, how to do password storage. So I'm going to skip some of this. We'll talk about using Assault, we'll talk about scrypt and bcrypt and ppkdf2, the problems with those, and my preference is using an HMAC for password storage. Just getting a little crypto here. So number one, what we're doing, what I'm talking about here is a developer is building a database. The user has given us a password at registration time. How do I store that password? How about plain text, Matt? Plain text password. Survey says?
I love it.
You love it as a hacker. As someone who wants security in code, it's the worst thing you can possibly do. Especially last year, we saw a whole huge number of high visibility password hacks. SQL injection, steal the password out of the database, the whole application's compromised at that point. So first thing, don't limit the type of characters or length of a user password. Let users use password managers and give you giant passwords, and you should be able to handle it. And when you use proper crypto, the size of what you store in your database will be the same, will be a consistent number of bytes regardless of how long the password is. We're using hashing-like techniques to store a password. Now, there's a caveat here. Anyone see Django get hit with a denial of service major vulnerability recently? Anyone see that? Django framework in Python uses the algorithm ppkdf2 to store the password, which I think is actually a reasonable choice. There's a lot of looping factor that slows it down. The reason they slow it down is to defend against things like GPU cracking systems trying to essentially brute force your crypto and how your password's stored. If your database is stolen, that's why we do this. And so Django in the past would allow us to have an infinitely long password. And again, ppkdf2 is going to crunch this and iterate over this before it creates a key to store. And so in Django, we saw attackers can provide a multi-megabyte size password and basically denial of service the whole system. And pretty much any Django application, even on heavy-duty hardware, was heavily vulnerable to this vulnerability. So I say, like the minimum password should be is about 9 characters today, in my opinion, and the maximum around 100 characters, maybe 160 at most. Beyond 160, there's no major cryptographic benefit. It can't be unlimited in size. Other than that, let users use any characters. And as a quick side note, what do you think of password policy? I think password policy is almost useless, to be honest with you. What's more effective than password policy is detecting if a user is using a commonly used password. We can go to the RockU dumps, the LinkedIn dumps, the Sony PlayStation dumps, and see what the world is using for passwords, normalize that list, get like a top 1 million password used list, and if a user ever gives you that password, you tell them, seriously, you've provided for us a password that fits our policy, but it's also a very commonly used password. We're not going to allow it. Please use something else. So I think that's actually more important than your traditional password policies. Okay, so next, we want to use a cryptographically strong, credential-specific salt. If we're using a hashing algorithm, which I don't recommend, but bear with me, so using a hashing algorithm, if you and I have the same password, like mine's FluffyBunny1 for most of my services, like yours, right? You use FluffyBunny1 all the time, right? Just work with me here. So when we use a hashing algorithm on FluffyBunny1, our hash will be the same. And I can use that to attack the system in certain ways if your database was dumped. But if you, at the time we register a new account, I'll build a random value for you, a different random value for me, and I'll stick it before the password before we protect it. Now we've deduplicated how our passwords are being stored. That's the main purpose of assault. It also defeats rainbow tables to some degree. It's not the real reason for assault. You use salt to deduplicate your ciphertext of what's being stored for that password. Step number 2. So number 3, use an HMAC. This is my preference. An HMAC, although it's a hash, it's an authenticated hash. Whenever you look at crypto, basic crypto is usually a bad idea. You always want to use the authenticated version of that crypto. It's always going to be stronger. So we have HMAC. It's basically 2 rounds of a hash, and you stick a key in with each round. That private key must be long, must be cryptographically sound, must be stored in a sound way. But the problem is key management is ridiculously difficult in most applications. So you want to use something like an HSM, and even more important than an HSM is the isolation of this cryptographic utility. So in my application, I don't believe you should be hard coding how the HMAC works or have that your application retrieve a key from an HSM. Even better is having a separate web service, and all it does is it takes a string, your salt and password, grabs the key from an HSM, runs the HMAC, and spits out the hash, and isolate that to a separate web service. Now, even if your application is hacked, there's no way to access the key, which is what's needed to reverse your password storage mechanism. Now that's well and good. It also scales because its HMACs are super fast. But many companies don't have the ability to manage that key, and many companies don't want to take the hit of building a separate service just for password storage. So if you want more of a quick advice with less scalability needs, then I recommend you use PBKDF2 or scrypt or bcrypt. These are essentially adaptive hashes. You give it a string, it spits back a hash or a key that you can put in the database. Then when the user logs in, you have their username, look up their salt, grab their password, run this protection algorithm, and see if what that returns is the same as what you've stored in your database. The problem with these algorithms, though, there's a work factor which slows it down. We slow it down to defeat supercomputers trying to crack this system. You can build a GPU cracking rig that does about 50 billion hashes per second and trying to crack a system like this. You can build that for a couple grand, and that's only going to get worse over time. So you really need to have this work factor be really high, making the algorithm really slow for them to be effective. How many times, who here is a developer, by the way? How many times have you been told, that feature you just built, man, that's way too fast. It's performing way too fast. Can you really slow that down for us, dude? Slow that down. We don't get asked to do this, except when it comes to password storage, and I think it's really bad advice in a situation where you need to scale. Because what people do is they'll use bcrypt, which is a common piece of advice. Then they try to scale, so they keep reducing the work factor to make it run faster, which defeats the point of it. So if you're getting started, use these. If you really want a heavy-duty, really secure, scalable system, you're better off using an HMAC. All right, so that's password storage. It's a little piece of authentication. Where did my image go? World of Warcraft. We'll just skip this. We know about multi-factor. What does multi-factor defeat? It defeats brute force attacks. That's the whole point of multi-factor. It also, when you're using multi-factor, when you're using multi-factor, your need for deeper password storage is also less important because it's a changing, multi-factor makes it a changing password over time. I think SMS is horrible for multi-factor though, and most systems are using it. We have all different kinds of ways to attack SMS, like the SMS swoop fraud. We have different Zipmos patching at the kernel level to steal SMS. We have different SMS swallowing attacks against Android. So SMS may reduce the risk of authentication problems, but it doesn't eliminate them. Now, the way to do multi-factor is what we saw Twitter do recently. They're not storing the key on their servers. Their requirement was even if our servers get hacked, I don't want the multi-factor mechanism that a lot of the celebrities who make our service valuable, I don't want them to get hacked. I want to be able to recover from that event. So the private key is created on the device. It's basic asymmetric crypto, and it's never stored in the actual servers of Twitter. So you can read more about that over at Ars Technica did a really good article that talks about the deep technical aspects of Twitter's new rollout. It's push notification. The key is only on the device. That's how we do multi-factor, in my opinion, in a consumer website at great scale. Next, forgot password. It's basically, again, we're talking about authentication best practices that we need developers to embrace. So forgot password is another multi-factor workflow. A lot of people use email to send a password reset link. How good is email from a security point of view, folks? It's not at all. So I like the forgot password workflows that we see in the banking industry now. They're asking for identity information up front, account number, email, date of birth, like 2 or 3 questions. They'll then require you to do a good security question. There's no such thing as a great security question. We have some good ones. We have a cheat sheet at OWASP that talks about how to figure out how to build good security questions. Once that's answered, we want to send them a token out of band. SMS is the worst. A dedicated token is best. Look, PayPal actually provides you with like a credit card that's actually a multi-factor token with a little computer in it. So we can do dedicated multi-factor tokens for pennies on the user. It's come down in that level in price. So we have ways to pull it off. And then we let the user reset their password. So even if email is compromised, multi-factor will not be fully compromised with a mechanism of this nature. All of my pictures disappeared for some reason. I took the hit to upgrade to Mavericks here, so maybe not the best choice. Let's just move on. Let's go into access control in a little bit more depth here. This is, again, one of the 10 foundation defenses we need for a good application, good secure application. So first we have access control anti-patterns, the hard-coded role checks in code, lack of a centralized access control mechanism, untrusted data driving identity parts of the access control decision, or a lack of addressing horizontal data contextual access control, if it's done at all. Access control logic that needs to be manually added to every single piece of code. Access control that's sticky per session, where even if I change a user's role, it's not going to take effect until they log off and log in. Or access control that requires me to configure every user on a user-by-user basis. These are anti-patterns that lead to poor access control design. And here's the same list in a more positive fashion. We want to build a centralized mechanism that does this, like we saw in Apache Shiro. We want to code to the activity, not the user or the role. We don't care who the user is. We care if they're allowed to access a certain feature or piece of data. I like to also build access control as a filter, where every request must go through this filter, and by default, we should deny. We should deny by default until we've configured that feature with a certain policy. We also want to change these entitlements, the user actual permissions a user has in real time. If I change a user's role, that next request, that new permission set should take effect. We want to also design this in a standardized way. We also, for data contextual access control, like we saw in the Winnebago example. We also want to build grouping for users and administrators and users and features to make it easy to configure large classes of users at once. I also think of content security policy as an access control kind of standard. So content security policy says, I'm going to take this is a cross-site scripting defensive mechanism. It's built into the browser. It's going to take a few years before a large number of users have browsers that support content security policy in a standard way. We've only seen it since Chrome 25 or later, Firefox 23 or later, and IE 10 or later. And they all have different kinds of way they implement CSP. Content Security Policy 1.1 is just coming out now. It's just becoming resolved. And what we have to do is you take all your JavaScript, put it in a separate JavaScript file, then you set a policy in a response header, that if any other JavaScript enters your application, it's rejected by default. This will stop large classes of reflective and stored XSS. We need to wait for the standard to solidify it for 1.1 and for more users to use browsers that support the standard. I see this as a kind of access control. Let's talk about query parameterization next. Hopefully this is something you're all very familiar with. The number one way web apps get attacked, in my opinion, is SQL injection. It's brutal. It's not a hit on an individual user, it's a hit on the whole application. And the kind of damage we can do with it is off the chart. We can steal any data, we can modify any data, we can also do command injection against the backend database. I traditionally have not been a fan of using input validation or firewalls to stop SQL injection. The research I've seen from Nick Galbraith and Zane Lackey from Etsy is really changing my mind on this. There are ways to do input validation to heavily reduce the risk of SQL injection. But if you want to fix the problem, we have to parameterize our queries. An attack as simple as this can take down a website. We have an update statement. We're trying to update a list of users. With that simple single quote semicolon, we can end the query early, and bang. Oops, what? Sorry, Mavericks. Okay, Mavericks. Go Apple. Love you, Apple. Come on. There we go. Update users, set email is quote, quote, semicolon. That's what the attack does. And instead of updating the email address from one user, it now empties the email address for the whole database. Because of 2 characters, we have got to take this seriously. The way you stop SQL injection is with query parameterization. And there are a lot of ways to do it. Every language that drives the web offers this query parameterization interface. We have it in PHP, we have placeholders, and we have bind statements to bind our untrusted data into those placeholders. We have it in .NET, same thing. We have our placeholders at name and at password, and we have our binding statement in the name and password text boxes. And so, bang, SQL injection goes away. We have the same thing in Java, both the prepared statement class and even in HQL, we have binding statements. Who knows about this already? Who is very familiar with query parameterization? Now, why is this a separate topic? Why am I not putting this under encoding? Or why am I not putting this under validation? Because it's neither of those. Anybody know what query parameterization actually does to protect your web application?
Separating command and data.
What happens, how is that done though at the database level? What happens is when you build the first statement with the question marks, that's your placeholders, that gets sent to the database before the untrusted data is sent to the database. The database sees that query with the question marks and builds a query plan. It pre-compiles the query and builds a query plan in the database in terms of how the database is going to retrieve this data. Builds all the Boolean logic tree to do this. And now that that query plan is built for that query, then the untrusted data is sent in where the placeholders are. The query plan is built already. The structure to retrieve that data is already compiled, so there's no way an injection attack can manipulate that data traversal tree. And SQL injection goes away. We've had this defense for almost 20 years. Early versions of Perl had this kind of defensive feature. So it's the only thing we can really rely on to completely stop SQL injection in code, in my opinion. We have it in Ruby. Ruby on Rails has a query parameterization-like API, the active record API. But the problem is, even when developers do the right thing, especially in early 2013 and 2012, we've seen major flaws in the framework. They're getting their act together. I think Ruby on Rails 4 does a lot to improve security, but they're really pushing hard on elegance for developers and performance, and security is still not, it's not their #1 concern, so we'll see what happens. Even the cesspool that is Cold Fusion supports query parameterization. Forgive me for that editorial. I once was hired to build they didn't tell me what language to work on. Paid me like huge rate to go do Cold Fusion. They didn't tell me. I get in and I start looking at the app. Okay, I'll take this job, and I see it's just a mess, really critical app. And I'm looking at this for about an hour, and I'm like, all right, I'm out of here. So I look around, grab my bags, I'm like, I'm out of here, and I'm sneaking out the door, and I go to the door, there's all the managers are there. What are you doing, Jim? Because I'm like, I'm out of here, I'm not gonna work on this app. I'm just not gonna work out for me. And they're all despondent, you're the 18th person who's walked away. It's oh, can we do anything to make you stay? I'm like, no. No, not gonna happen. All right, Cold Fusion, all right. So even old school Perl has this. So if your developers don't know about this already, we have a big problem. If you're approaching application security for the first time in your organization, which a lot of folks are, from a defensive point of view, I recommend you go through and fix all of your queries in every application and just fix SQL injection in one pass. This will test your organization's ability to actually do remediation. If you can't eliminate SQL injection in all your code, you have bigger organizational and structural problems. And I've seen that happen, and those organizations are in a lot of trouble when it comes to this topic. So it's a great way to start, again. Just fix all your queries, and it's available, this defense is available in any language. It again tests your organization's ability to deal with this very, very dangerous threat. So far, so good, everyone? What's next? Let's talk about encoding next. Encoding is the main defense needed to stop injection, and to stop non-SQL injection type of injection. SQL injection is fixed with query parameterization. Things like LDAP injection and cross-site scripting, which is just JavaScript injection, these are fixed by encoding. We look at our standard cross-site scripting attack, where we are grabbing the user. So this attack happens when I, as the attacker, embed this JavaScript into the application. We may have a feature like a chat board. I get this code in, you look at it while you're authenticated, I grab your cookie, attach it to a URL I control, load an image in JavaScript. The user won't even see this happen, and now that I've forced that victim to send a request to my server with a copy of their cookie, and I can compromise that account pretty easily at that point. Or I can deface the whole website in a very trivial fashion. Document body inner HTML, I own the whole page. I suspect this is how PHP.NET went down. We see a lot of JavaScript all over PHP.NET that's compromised potentially the whole PHP language. We'll see how that falls out. XSS, cross-site scripting, which is a bad name, it's just JavaScript injection. XSS happens all the time. When we audit applications at White Hat, we see cross-site scripting in pretty much every single application we look at. It's rare where our app is fully resistant to this risk. And it's human nature. When this vulnerability comes up, or these reports come up over and over again that you have cross-site scripting, folks become desensitized to it and stop caring about it. And that's a really dangerous path to go down. As SQL injection is on the wane, as more companies get it and fix it, attackers just shift to cross-site scripting to attack your application. And the things we can do with it are off the chart. We can use JavaScript attacks to own the whole world through advertising networks like Matt Johansson just spoke about in his last section. We can steal individual sessions. We can deface a website. We can port scan with it. We can undermine cross-site request forgery defenses. We can redirect the user, load scripts from third-party sites. Data theft, keystroke logging, dogs and cats sleeping together. It is a huge problem that we do have to address. And this is really hard to address. So here's my grid of how you stop cross-site scripting. It's a combination of encoding, tactical validation, avoiding certain APIs that are changing. It is using frameworks like jQuery in the proper fashion. It is a difficult challenge to get this right. But let's talk about the main defense encoding. When your browser sees this character, it thinks it's code. It thinks you're starting a new tag. But when your browser sees this character, these series of characters, the HTML entity, it's going to render a less than sign on the page without actually treating it like code. It's just display data. So when we want to build, I'm a Java guy, I'll use a Java example. We have a project that is an output encoding library in Java. Java doesn't have this library. We made a request to Sun, or at the time Sun, now Oracle, to build this library in, and they're like, core Java is for many different kinds of Java applications, not just web. We may build this into JEE someday, but we'll never put it in the core Java. So we'll never see an encoder like this in the core Java language. We need a third-party library to do this. My favorite is the OWASP Java encoder project. It was written by Jeff Ikonowski from SuccessFactors at the time. And it's one of the most, and he actually went and downloaded the source code to WebKit and all the different browser rendering engines and studied how they work and built his encoder not as a security guy with a good theory, but as a developer who really understands how HTML is generated in the browser. That's what triggered how he built this defense. And it's super fast and rock solid from a security point of view. So you do this encoding, of course, in the user interface. While we're building a dynamic web application, we put it in the middle of a text field. We want to use attribute encoding. We put it in a text area. We want to do HTML encoding. We put it in a JavaScript event handler. We want to do JavaScript attribute encoding. When we put it in script block, like a variable assignment, we do JavaScript block encoding. It's a very complete API that gives you encoding for even the most granular context. You can get away with just using 2 or 3 of these if you want, but if you really want to build like your own auto-escaping template, or if you have a really high security app that's complex, that you really need to build complete assurance for, you're going to need all of these different APIs for different XML encodings when building dynamic XML, for CSS strings and URLs, for different context in JavaScript. This is a complete API for the output encoding need there. And again, it was written by a really serious developer professional. Some of the critiques I have of some of the OWASP projects around secure coding, they were built by security guys with good intentions, but guys that were not professional developers. And so, like, especially the ISAPI project, which we spent a lot of time promoting, this was written by really good security guys who were really not professional developers. And the design pattern problems and anti-patterns in ISAPI is so prolific, I don't recommend it anymore. And I want to recommend it. I'm a OWASP board member. I need to care about these things. But I got to be honest, it's something I would never wish upon. I would never wish that upon anyone, to go through the hell that is configuring, using, and depending on ISAPI. So other encoding libraries I do think do fit that production quality characteristic. Ruby on Rails has their own util library with a contextual output encoder in Ruby on Rails 4. The Reform, old school Reform project are the only encoders I see in Perl and classic ASP, in Python. I don't see an encoder in Python. I think a lot of people write their own. But this is an old school project that will give you a good production quality baseline for encoding in some languages that don't have other encoders to this day. This is like an 8-year-old project. We do have ISAPI. A lot of people use it already, so I've seen them rip the encoder, and most people use ISAPI for the encoder alone. It can be ripped out if you need it, but proceed with caution. Unless you're really willing to invest a lot of time in forking the library, it's not going to stand the test of time. Then there's the .NET anti-XSS library. It's probably the best encoding library that's native to a language, and it's contextual enough to be effective in the real world. So that's output encoding. And again, I hate this, but we need to go to a lot of third-party libraries in most languages. The Ruby on Rails 4 and .NET are the few examples where it's really built into the language. So let's talk about validation. And I'm going to talk about, we all know about regular expressions and input validation. I'm going to talk about a couple of the edge cases, the more complex validation techniques that we need to master to build a secure web application. One is HTML input. This is a cross-site scripting vector. There's 2 widgets that developers use that's a WYSIWYG editor in a web page. That's TinyMCE, written by Spock, and I don't think it's actually the Spock from Star Trek. I think it's just a guy using the name Spock. But anyways, there's also CK Editor. These are WYSIWYG editors that convert a text area to a full text editor. How do these text editors submit that rich text? Bullet lists, highlighted text, different fonts, embedded images. Well, they submit it as a chunk of HTML. And what if you do output encoding on that chunk of HTML? What do you get? You get code on page. It's not going to launch an attack. It will be safe, but you're breaking the feature. We need to actually render that HTML safely. So Josh, can you build me a regular expression, please, by tomorrow that sanitizes any third-party HTML without breaking it and cleans out any JavaScript so I can safely render it for other users? Can I have that tomorrow, please?
Can you do that by next year?
That's the problem. Many have tried to do that, and very large, complex, regular expressions lead to denial of service vectors. It's also a kind of feature that we just can't build in a reasonable amount of time. Enter the OWASP HTML Sanitizer project. Again, I'm very Java-centric, so I'm going to give you a Java example to start with. Again, this was not written, there's another project at OWASP, Anti-SAMI, which is actually a really good project. It's pretty safe, but it has performance problems and configuration problems. It's not being well maintained, and it was not written by a pro developer. It was written by a security guy who's a security guy first and a developer second. We need to encourage developers who are pro developers and give them security assistance to really build libraries that will stand the test of time. This is written by Mike Samuel, who's the lead security engineer for Google's AppSec team, and he donated this to OWASP as a counterpoint to anti-SAMI. It's trivial to use, it's programmatic, no XML config, it's super fast, we've gone through a lot of gone through a lot of adversarial testing, and we found bugs in it. We fixed them within hours. So that's the key. We've seen bugs in anti-SAMI that have been unfixed for months, in some cases years. So we need. I'm less concerned about a large team supporting it than I am about one expert who cares supporting it. I'm much more concerned about small single-use libraries than libraries that try to boil the ocean in terms of security. So we give the developer this library, they drop it in, no dependencies. They can build a basic policy here. Here they're saying, give me a new policy, allow A links, HTTPS only, allow href and A elements, no relative links build. I can send in any untrusted HTML, and what comes out will abide by that policy and be safe to render to other users. This is a specialized validation technique. Other HTML sanitizers, we have the Kaha project, the JS HTML sanitizer as a pure JavaScript sanitizer. We have Python, the Bleach project. In PHP, we used to recommend HTML Purifier. It's not really being maintained. So the HTML Laud project is a much more in-depth and well-maintained and much more secure and performance-friendly PHP HTML sanitization library. In .NET, we used to recommend the anti-XSS getSafe HTML API, which is way too aggressive. It's secure, but it's gonna break functionality when using these WYSIWYG editors. I prefer the HTML Agility Pack, a third-party add-on that's configurable and is much more feature-rich when you need this kind of sanitization. Ruby on Rails has the HTML class built in that provides this kind of API in Ruby on Rails 4. Another specialized validation technique we need is file upload security. When you're letting users upload files to your server, there's so many little things we need to take care of. The key thing, I'll quickly do two things. We need to, when the user gives us a file name for an upload, multi-part form, we never use that file name to save the file. We write our own file name or use the primary key of the database entry and save it with the trusted name. Never want to use the name that the user gives us. We also want to do something called image rewriting. Never trust an image a user uploads to you. Use an image library like CKEditor or, the GD+, or the ImageMagick library. Load the image, change it by 1 pixel, rewrite it. If any of that fails, it's not a valid image. So these are techniques we can use to do file upload security well. Let's talk about data protection and privacy next. The whole CA infrastructure is a freaking joke. There are about 500 different CAs in the world today. Many of them have sold their private CA certificate to public companies, to corporations, to allow them to do man-in-the-middle in real time without any browser warning. And we saw, I'm not going to mention any names that would not be appropriate, TrustWave, but they came clean. I don't want to blame them because they came clean about it. They admitted they made a mistake. They revoked the cert. They promised they would never do it again. And more important, they said something which I really agree with. They said, many other of our peers in the CA world have done this as well. So we can talk about TLS1 and TLS2 and Beast and Crime and all these attacks, but the CA system is heavily broken in my opinion, and we need something better. And I really don't know what that is. So here's some things that we can do to get around the problems of the CA system. The number one thing is certificate pinning. When you're building a mobile app, you can take the public certificate that's been signed by a CA and hard code it in your app. That way, if someone's man-in-the-middling you and giving you a fake fraudulent but properly signed certificate, you'll detect that because it doesn't match what's truly on your server. This doesn't work in browsers yet. Chrome and Firefox will support it, but mobile apps, Android, the Android Chrome browser supports this. A lot of the .NET infrastructure APIs support this. This is a way to detect if someone has a fraudulent private CA certificate and is trying to man-the-middle you with it by giving you a fraudulent but properly signed by a CA certificate. There's also something that Nick Galbraith talked about yesterday in his keynote. He talked about certificate creation transparency, where Google is driving this, where they want to publicize every single certificate created by every single CA, just put it in a public text file. So we have the transparency of seeing what certificates are being created. So if some CA is creating their own fraudulent certificate for Facebook, we will see that. This will also help some of the problems we see in the CA system. So that's that's transport security. Again, the best we have is certificate pinning. We have strict transport security. We have certificate transparency, certificate creation transparency. These will do a lot to make the current SSL HTTPS system more sound from an authenticity point of view. What about cryptographic storage? We tend to recommend AES. In Java, the default is ECB mode, which is basically plain text. We're recommending now GCM mode, which is not available in most languages or browsers. So we're really stuck with AES CBC mode. We need a unique IV per message and the proper padding and proper key storage and confidentiality. We need to do that. That gives us confidentiality. Then we HMAC your ciphertext to get integrity. You want to derive that integrity and confidentiality keys from the same master key. And don't forget to generate a master key from a good random source. Good luck with that. Yeah, so most developers are not going to get this right. And frankly, some of the best applied crypto developers in the world are not getting this right. So again, this is kind of a framework issue. Bring in Google Quasar. Google Quasar is one of the best it's Java, Python, and C based. One of the best applied crypto libraries for cryptographic storage I've seen. The developer will need, once you've configured it, the developer will need to do two things. Cryptor, encrypt secret message, and then cryptor, decrypt ciphertext. That's the only API that I want developers to have to hit to do good cryptographic storage. And we can configure it to point to an HSM or some key management. Even better, take this whole system and isolate it in a separate web service. So even if your web app is compromised, your cryptographic applied crypto is not compromised. This is the way to roll. It's an open source library, been around for several years. It's well maintained. It gets all the crazy things like the proper padding, which mode to use, and IV management, initialization vector management. It gets all that stuff right. So I highly recommend this kind of thinking for any language. I don't know how to recommend this for other languages. This will give us Java, Python, and C++ industrial class crypto. Next, how much time do I have, by the way? How are we doing on time? I'm out of time. Can I see your sign for a second? Are we really out of time? Okay, we are. So app layer intrusion detection. Again, this is the last few slides I'll do. Blatant SQL injection attacks, we can detect that at the request. And I did not believe that even just a few months ago. Zane and Nick have really led the research in building really awesome techniques to detect SQL injection. You know what the name of Nick's library is that does this?
LibInject.
Pardon me? We have LibInject, which is a input validation layer to detect possible SQL injection attacks. There's also a technique where you have your table names in your database, have them be really unique names, not things like user. That we're going to see that word a lot in normal input. Things like TB_user. We'll never see that in normal input. And when we do see a table name in a request, we can usually safely just reject it to stop potential SQL injection attacks. These do not solve all SQL injection potential problems, but it lets you know really early on when you're being attacked. Last note, things like a radio button. Suppose or a checkbox. If you have a checkbox, you should get back two values. If it's checked, you get the value of the checkbox. If it's unchecked, you get an empty string. If anything else shows up in the request for that checkbox, you are being attacked. Someone has an intercepting proxy and is messing with your application in a way that a user with a normal browser can never do. At OWASP, we have the App Sensor project that helps with this in Java. There are so many ways to add intrusion detection in your app easily so you can detect when you're under attack very early. Almost nobody does this. Do you do this, Zane? Do you do this?
The hidden fields one? No, we don't. Facebook does that.
Do you do, I mean, just in general, do you do input intrusion detection in your apps?
Yes.
Very few people do this, and if you did, you would have so much knowledge early on whether you're being attacked. When do most people know when they've been attacked? When they see it in the newspaper, or see it on Pastebin? So this is my awareness 1-hour presentation, how to approach secure code. I'm very grateful you spent the time to come here. Any questions? I'm at Manico on Twitter. Jim@owasp.org is my nonprofit address. Jim.manico@whitehatsec is my commercial address. And I'll put this presentation up on SlideShare before the week is out. Rock on, go write secure code. Thank you very much, everybody.